Okay, thank you. Okay, all right, you guys. So straightforward case is angle, side angle. Why is it important that if you guys have two angles, can you figure out the third angle? If you guys have two angles, do you need anything special to figure out the third angle? You can just subtract it from 180, right? So this is the straightforward case. It's easy. You already knew how to figure out the third angle before we did law of sines. Okay, so law of sines straightforward case is what you're responsible for knowing. So underneath here, this is a cell geo. You are responsible for knowing this. This will be on the test. And then case 2 is what, so that, by the way, maybe you guys can add notes here. This is Friday's video. So if you guys didn't get a chance, or Thursday's video, to watch that, I would do so. That it's like a 7-minute video. Okay, case 2 was last night's video on ambiguous case. And you want to think about it. Remember when I said there's no buts in geometry? You can kind of think about, well, there's buts in algebra 2 trig. This is where you guys will cover ambiguous case and be responsible for it. So if you spell the ambiguous case backwards, that's where the but comes in, SSA. Okay, and this is the ambiguous case. So notice that this one, you only have a single angle. You can use law of sines with it because you have an angle and a side across from it, but the ambiguous part means that there could be 0 triangles that result from it, 1 triangle or 2 triangles. And again, watch the demo. It's a little bit clearer to see on the demo with the GeoGebra, because you guys can see why it becomes ambiguous. Okay, so for this one, can you guys you're not responsible for this until algebra 2 trig. It really was an extension. So not on test. This was last night's video, Monday's video. Okay, you had a few homework questions on it. So what I'm gonna do now is move to just encapsulate things a little bit more, summarize things a little bit more. I'm gonna do one that is straightforward and one that is ambiguous with you guys. And what I might do is just record the video on the second ambiguous case, so it saves me a little bit of time here. So what I would encourage you guys to do is, it does not have to be drawn to scale, but problem number 1 on your homework assignment from last night, what I would do is just draw a random triangle, okay? And then label it A, B, and C. And not drawn to scale, but angle A is given as 36 degrees. Angle B is given as 48 degrees. Little a, which means side A across from angle A, is 8. And then assess to see what you guys know. You basically know it's the straightforward case, the case that you're responsible for. If right off the bat, you guys can solve for that missing angle. Okay, have your calculator ready. And then let's work on calculator skills as well. Can I have you guys go ahead and figure out side C for me? Figure out side C and then type it into the chat. Okay, I'm gonna move quickly through this one. 96 degrees, excellent. You just subtract the 2 angles from 180 degrees to get 96 degrees. So then you look to see, can I use law of sines? So we're gonna eventually mix in law of cosines, but you always should try law of sines first. Besides the fact that there's the ambiguous case, it's the much easier formula to deal with. So if I have an angle and a side across from that, I'm going to use law of sines. Automatically start with law of sines. Okay, so the one that I have the most information on, where I have both the angle and the side across from it, is angle A, or A. So what I'm going to do is set up my proportion. Sine of the angle over the side is equal to, and let's say I had to figure out, like in this problem, they want me to figure out B and C. So I'm going to do one by one. Sine of angle B. Angle B is 48 degrees over little b. Can I have you guys in the chat? We're just going to do B, and then I'll set up C, and then just verify that you guys have the correct answer. Can I have you guys go ahead and solve for it? So cross multiply means that you're going to have B times sine of 36 equals 8 times sine of 48. And nice job. I see some of you guys starting to pick up the pattern, being able to do this in less steps, but still getting the right answer. This says round out to the nearest tenth. Christian, I believe it was you that was starting to on your homework assignment. I can tell when you guys start doing more of these problems, it's just like, okay, I know it's going to be 8 sine of 48 divided by sine of 36 is B. And that's okay. That's what you want to get to is the comfort level where you don't have to necessarily maybe write out as much as I did here. But B, when you come up with the answer, go ahead and type it into the chat. Matthew, you okay so far? I just simply had sine of 36 over 8. So it's sine of the angle over the side opposite, and then same thing, but this time we're trying to figure out the side opposite, which is B. Yeah, so I would just enter this all in on the calculator at once. Okay, yeah, so I would do 8 times sine of 48 in parentheses and then divide by sine of 36. Okay, very nice, you guys. 10.1 is the correct answer for that. And then, so if you had more than one thing to solve for, what I would do is I would still keep the same initial ratio, like this sine of 36 over 8. That's the one I have the most information on. So I'm going to keep that in my second proportion as well for C. And then this time sine of angle C, which we solved was 96 degrees, all over, we're trying to solve for little c, and then multiply that out. Okay, the answer to this one is 13.5. So this is the straightforward case. This is what you're responsible for knowing. Both law of sines and law of cosines today are ways to solve for triangles that are not right triangles. Okay, so what I'm going to do is case 2 now with you guys. So problem 2 is case 2. Now this case 2 results in an answer that is different from your the example that I did with you guys last night. So I wanted to do this one as well. So let's draw, not drawn to scale. I'm going to take a picture of this real quick and, or let me shrink it. Just draw a random triangle, you guys. Okay, spell out what you guys have. You have a side, let me make it red here. You have a side here, and an angle that is not included. So again, when you spell this, this is a pain in the butt to solve, okay? So the ones where you have a side, and an angle that is not included, and it spells however you want to interpret this. But this is a pain in the butt to solve. This is the one where you guys have to understand that it's an ambiguous case. How do I know it's law of sines? Well, I know it's law of sines because I have an angle and a side across from it. If it's SSA, it is the ambiguous case, and I do have to take a few extra steps for this. Okay, so without even having to deal with the picture, I'll kind of go through the steps that you guys would do for a problem like this. Okay, so you still set it up the same way. Let's say you had sine of 26.3 over 7. And that's equal to, and then if you guys had to pick a side that, am I missing information here? I think I forgot to label C is equal to 6. Which side do you guys have to solve for, or which angle do you guys have to solve for first? Here you don't have a choice. So let's say you thought A, you're missing the angle and you're missing the side. So do you see how C, you have the side given to you? So then you can solve for C. Okay, so you have to pick the side or the angle that you actually have the side for, which is C. So we would do sine of, angle C over side C is 6. Okay, any questions so far? This one, you have no choice. You guys have to solve for C first because C is given the side length, whereas A, you don't have any information on the angle or the side. So not enough information to start with A. Okay, so go ahead and solve this, you guys. So if you did, I'm going to show you guys on the calculator because someone here was saying that they didn't know how to solve for the angle measure if the angle measure was missing. So let's say you cross multiplied, you divided by 7. When you get to the part where C is stuck inside of sine, that's when you guys would do inverse to isolate your angle. Okay, so inverse sine of both sides. If you know how to do this, if you already did it, can I have you guys take a moment and make sure that you understand it? I wrote it down here so I didn't have to switch back and forth on the screen. No, you just have to know how to apply it. Okay, you guys, if you had trouble with finding inverse, Matthew. Oh, this is the question you had where, how do you isolate C? Oh, really? Oh, okay. I think my brain was just not functioning properly yesterday. Okay. Can you guys in the chat, if you want me to show you guys how to do this on the calculator, can you let me know? You guys can do a direct message. Otherwise, I'm going to move on to the second part of the explanation. Okay, so do you see how it's inverse sine of both sides? So that's the inverse is gonna undo the sine. So that's gonna isolate C. So now C is by itself. You just have to enter this all into the calculator. Above this step? Yeah. Cross multiply. So actually you would just see 6 sine of 26.3, 7 times sine C, and then I divided 7 on both sides to get rid of this 7 here. There was like a question on the test where I forgot to, I simplified the radical instead of moving it in the simplified radical. How would I do it? Ask me in a minute on that one. On the quiz, right? Yeah. I messed up quite a few questions by simplifying the rad instead of just moving it in. I mean, like solving the rad instead of moving it. Okay. And then I'll probably have you write out one of the questions up there so I can see. All right, you guys, there was someone who asked, how do you do that on the calculator? So all of that expression we're going to input at once. So on your calculator, please do this along with me if you guys have a question about it. We're going to do inverse sine. So function, go to inverse sine of a fraction, a giant fraction. So if you guys have a giant fraction, underneath the wrench, you guys see an A over B. Underneath the wrench, you see an A over B. Do you see it, Dion? The far right. Do you see A over B? Click on that. When you click on that, you can enter in the numerator. So 6 sine of 26.3, all on the top. Whoops. And then divided by 7. Do you see the answer on the right? 22.3. Okay, so 22.3 is the answer. Let me go back and talk about the ambiguous case at this point. So you guys, once you figure out this angle, the first angle that you solved for, call it C sub 1. This is the ambiguous part. Okay, so your first angle C is equal to 22.3 degrees. When you saw that demo that I showed you on Monday, this is the step right after you guys solve for your first angle. you're going to assume, okay, maybe there might be another triangle that works with it. And if it does, then the secondary C sub 2 or the secondary possibility for C would be the supplement of this angle. And by supplement, it means it adds up to 180, or I can find that other angle by subtracting 22.3 from 180. Can you guys all find that value for me? What is 180 minus 22.3?
When we're doing science, we never round, right?
Just according to whatever it says. Like if it says to the nearest degree, then you would round to the nearest degree or nearest tenth.
Like, do they solve first and then round? Or...
Yeah, solve first and round. Yeah. Yeah, so Matthew asked a good question. I would not do like this as a bunch of baby steps, like 6 sine of 26.3 divided by 7, then take the inverse. Because as you guys round along the way, you kind of make a pure answer estimated along the way. So you want to keep it as pure as possible by doing it all in. That's why I want you guys to use Desmos and enter it in all at once. So you're not rounding along the way. Okay, 157.7. So in theory, right now in my mind, I'm picturing that I could have a triangle where one angle is 22.3, it's an acute angle, or it might be that that angle is a obtuse angle. And in that demo, that's where you guys had the swinging pendulum, where it created an obtuse triangle or an acute triangle. So then the way that I verify if this is possible is I find my third missing side. So right now you guys were given that angle B was equal to 26.3. Notice that I did not write angle B as two separate values. If that was the value given to me, that has to be fixed. I can't change. This is not ambiguous at all. This is the part where they gave me that value. So that value for B is fixed. So there is no such thing as B sub 1, B sub 2. However, if I were to calculate the third angle, angle A, okay, if these were two angles of a triangle, the third angle would be different from the two angles if the triangle had these two as the angle measures. So let's go ahead and calculate A sub 1. We would do that by subtracting out 22.3 and subtracting out 26.3, the two angle measures prior. So can you guys tell me what A sub 1 is equal to? Okay, and the way that you can say whether or not this is a possibility, this one will always work out. Your C sub 1s, your sub 1s or your first triangle, that should always work. So this here, these are the dimensions of my first possible triangle. Now I'm trying to, with the ambiguous case, trying to see, is there a secondary triangle here that works? So if this is C sub 2 and this is B, then to figure out this, the second angle for A, I would do the same step, take 180, minus out 157.7 and 26.3. And can you guys tell me what you get when you do that? Okay, negative degree. Right now, for this class, does it make sense for me to have a negative degree for a triangle measure, like a third angle, be negative? No. So what that tells me is that in this ambiguous situation, there was actually only one triangle that worked out with the given original dimensions. Negative degrees, in the context of a triangle, there's no such thing as a negative degree, right? But when we expand out, when we talk about the unit circle and degree measures beyond just 180 degrees, yes, it is possible. So you guys will see that in trig with the unit circle, you'll see 360 degrees and an infinite number of degrees, both positive and negative. But for now, when we think about triangles, because this is supposed to be the dimensions of a triangle, it's not possible for me to have a negative. Now, if this ended up giving you guys a positive value, then that means it works. So therefore, there were two possible triangles, this triangle and this triangle. So that's the only difference in determining in the ambiguous case whether you have 1, 0, or none. So in this case, you have one triangle that works. If you end up with, like in this calculation, in this step right here, where you guys get a value that your calculator is saying it's not possible for this to be equal, then it's a possibility that you might have no triangles that work with that, that initial setup. So that's the ambiguous case. I want you guys to try, and if you guys want me to, I can solve that on Thursday with you guys. I want you guys to try 5. That's the ambiguous case where it does end up yielding a second question that, or a second triangle that works. Okay, and hopefully as you work on this, it gets easier and easier to do. Okay, so law of cosines next. I just have 2 examples with you. It's kind of a long formula, but one that's not difficult to remember. So both for Algebra 2 Trig, this course, you guys are responsible for law of cosines. So let's go ahead and go down to here. And can you guys go ahead and call this? This is 8.6 in your textbook if you want to reference. This is law of cosines. Okay, and you use it specifically for side angle side or side side side. So when you say side angle side, the angle is included between 2 sides. Okay, and the law itself, there's 3 different formulas for it. They're not very difficult to remember if you think about it's a form of like the Pythagorean theorem. So the 3 different formulas that I'll put a box around that you'll have to know is, let's say the first one, we think of Pythagorean theorem. Okay, so let's say instead of c squared though, we start with a squared. A squared equals b squared plus c squared, assuming a is like, you know, like this is similar to the Pythagorean theorem, but it's not because we're able to use this for non-right triangles. Okay, so the other part of it is not very difficult to remember once I tell you guys how to come up with it, but it is a long formula. So minus 2 times b times c cosine of a, cosine of capital A, which is the angle. Do you guys notice how a here and a here matches? Okay, so your n's are going to be the same variable. Okay, little a squared, little b squared, little c squared are talking about side lengths, and then capital A is the angle measure. Okay, so notice also that in between that, you guys have this b, this c, and then minus 2bc. Okay, this is the law of cosine, so it'll be cosine instead of sine that you guys see in the trig formula itself. Okay, now if you guys write the other 2 variations of this, it's going to be the same exact thing except the variables are switched around. So what if you guys had b squared here? Okay, that would mean that this is a squared plus c squared. Can you guys type into the chat, what do you guys think the remainder of that would look like? Following the same pattern that you see above, what do you think the remainder of that would look like? You guys out loud, what do you guys think the rest of it would look like? Okay, good, you guys in the chat. Okay, so if it were to match the above, it would be minus 2ac, and then cosine of capital B. Very good. Very nice, you guys. Now come up with the third one. The third one would be the same exact formula, right? Except this time we haven't done c squared. So c squared, and then try to fill out the rest of it. What do you guys think the rest of it would look like? You don't have to type it out. I know it looks intimidating and it looks a little scary to have to apply these formulas, but it's actually, I think in some ways, preferred to over law of sines for some students. There is no ambiguous case here. There are going to be 2 parts where I'm gonna just tell you guys, this is what, if you get this situation, this is what you do. But there's no solid, and I hate it when this happens, there's no solid way for me to explain why you would do it that way until you guys get to trig. And it involves what we consider eventually the domain of the functions for trig, but because you're not there yet, the explanation is not going to make any sense, because for you guys, you just know of sine and cosine as a ratio of side lengths, that's the relationship between the angle and the side lengths. There's more to it. Obviously, that's why there's a whole unit on trig in Algebra 2 trig. So for now, the two examples that I do, they're pretty straightforward. I'll put like a little star beside it and tell you guys, you know, this is the recommended route to take if this occurs. Okay, so let's say it says solve for the triangle, which means basically find everything. Okay, so this is what you're given for the triangle. Example number 1. Solve for the triangle. Solve for missing sides and angles. Sketch the picture. Okay, you guys, so let me walk you guys through a train of thought that I have when I see these problems. And I record notes with you guys and I say, you know, when you have angle, angle, side, or side, angle, or side, angle, that you would use law of sines. But in my mind, I can look at a problem and not remember all of that like 3-letter acronym and know whether to use law of sines or law of cosines. Can you guys in the chat type out why you could not use law of sines for this one? Why can't you use law of sines? Yes. Okay, it's as simple as that, you guys. So if you keep it simple and you just think, okay, when you're trying to solve these problems that are not right triangle, you're going to try law of sines. If you can't use law of sines, then you have to use law of cosines. So you're gonna begin your thought process like that, and rather than thinking of it like overthinking things, just think, I'm missing little c. I don't have enough information to use law of sines. The law of sines formula is more simple than the above formula. So if whenever you're faced with which one should you should use law of sines first. If you can't use law of sines, you're going to use law of cosines. Now, with law of cosines, there's 3 formulas to choose from. Okay, so when you're trying to figure out which one of these 3 am I going to solve for, you're going to look at what you have. Okay, so you have a situation in which you have side, angle, side. Okay, so if you are trying to figure out the third missing side, that third missing side is little c. Notice that you have angle c, and you have little a, and you have little b. So if it helps you guys at first, you might want to write out, okay, I have little a, oops. Let me write that out. I have little a, I have little b, and I have capital C here. Okay, then look for the formula that has all 3 of those things in it. So that would mean that I have to solve for little c. And so the third formula that you guys see here is going to allow you to solve for little c, given that you know what A, B, and capital C are. Okay, so generally it's going to be the side across from the angle measure that you're looking for. Scroll up this way. Okay. So if you guys can write out that formula, or actually leave the formula because we already have it written down. We're going to solve for c squared first. Let's plug in a squared plus b squared. And I tell my Algebra 2 trig students, hey, just leave everything unsimplified. Like leave things like this. You don't have to square it out. You have these are calculator questions, so you're going to use your calculator to help you out. So 9 squared plus 11 squared minus 2 times 9 times 11, those numbers are repeated. And then cosine of the angle measure, c. So remember again, this matches this. So cosine of c is 28. This is just one giant expression that your calculator will do for you. Okay, so then after that, how do you guys solve for c? If this is c squared, what would you guys have to do on both sides? How do you undo squaring? Okay, you square root both sides. All right, everybody should have their calculator open. And everybody should try to enter that in as one giant expression and not to do it as a separate step. So I'm going to exit this and go into Desmos Calculator. Oh, you're still writing it down? Okay, I'll leave it a minute here. Try to do that in one step, you guys. Can you do square root of that entire expression? You got it, Matthew? When you're solving for missing sides and lengths, you should never end up with a negative answer. If you did, you should at least you might with the ambiguous case, and that's going to lead you to the conclusion that that's not possible, but you should end up with positive values so that you can, so that it makes sense. No, yeah, so Matthew asked the question, please don't simplify anything. Let your calculator do all the work for you. So go to Desmos if you haven't done so already. Let's round to the nearest 10th on that. Okay, so you're going to hit square root, and then you'll enter in a squared or 9 squared. The squared button is that a squared, by the way, makes it a little bit faster, plus 11 squared minus 2 times 9 times 11. And this is why I don't want you guys to use your phone, because your phone doesn't allow you to enter it in all at once. So you see how easy that was? We don't have any rounding errors because we're entering it all at once. Okay, everybody look at the screen and make sure that that's how you are entering in your answers, or sorry, entering in your expression to get 5.2 rounded to the nearest 10th. Okay, it does say solve for the triangle. So once you guys get the third side, can you guys use law of sines from there? Yes, okay, so good. So once you guys can use law of sines, that's going to be the way you want to go, because that's going to be much easier than using this giant formula. Let me go back now to here. C is equal to 5.2. Okay, there's going to be a recommendation here. You're going to use law of sines from here to find angle. And you're going to specifically start with the side that's opposite the smaller, or sorry, find the angle opposite the smaller side. Why? Okay, so this is where it's going to get fuzzy for you. Okay, law of sines, sine as a function is only defined for acute angles or angles between 0 and 90 degrees. And that has to do with the domain for which, when we eventually learn about the inverse sine and its graph, it's only possible for inverse sine to be values that are between negative power 2 and power 2, or when we just think of positive triangles, 0 to pi over 2. Why am I saying pi over 2? You guys have no idea what pi over 2 is. 0 to 90 degrees. Okay, so then it basically ignores values that are possible for obtuse angles. And so when you're picking up the law of sines, just keep in mind that you want to start with the angle opposite the smaller side. So how do I know which one's the smaller side? The angle opposite the smaller side would therefore be A. Okay, A is 9. B is 11. C is where is the information that we already know. Okay, so let's go ahead and use law of sines here. We have to begin with C, right? Because C is the only one we actually have the angle measure for and the side across. So sine of 28 over 5.2 is equal to, and then we're going to solve for A next, sine of angle A over little 9. Okay, so can I have you guys take a moment, solve, look at my work if you guys have to, but try to solve on your own at this point. Round out to the nearest tenth. What do you guys get for angle A? Okay, Cody. Yeah, I think I was going to suggest you just check it again. Matthew, can you make sure you get that right answer on the calculator for that? Jaden, are you doing okay?
Yes.
And Dion, does it make sense with the calculator now? Okay. Yeah, yeah, a little bit because, you know, inverse isn't as straightforward as the other one. Yes, so by the way, those of you guys typing it in, those are all correct answers that I see, 54.3, very nice, you guys. Here's my next question to you guys, so 54.3 degrees. How do you, so we basically have everything but angle B. How would you guys go about solving for angle B? How would you guys solve for angle B? Do you have to do law of sines again, or what would you guys do? Okay, good, you guys. Yeah, you already have the other two angles, so just simply subtract the measure of the other two angles. So 180. Yeah, you can round it to 50 to the tenths place. Yes, so subtract from 180. And usually when they say solve the triangle, it means just basically solve for anything missing. So good. So if you guys subtracted it, you should have gotten 97.7 degrees. Okay, and then our last example is going to be law of cosines as well, but this time it's the other scenario. So for this one, again, you always want to think of this. This is law of cosines with side, side, side. But again, if you don't memorize all of those three-letter acronyms, the simple thing to do is simply just to ask yourself, could you use law of sines first? Okay, I would always start with law of sines. It's the simpler formula to begin with. So let's say you guys were given little b is 1.8, little a is 5.6, and little c is 6.5. Give you guys a minute to write that. When you finish copying down that figure, in the chat, can you explain, or yes or no, can you guys use law of sines here? So always begin any one of these problems with, I'm going to try to use law of sines. Can I use law of sines? Okay, you cannot use law of sines, right? So you don't have an angle across any, you don't have any of the angles, so you can't use law of sines. So that's where you guys are going to move automatically to law of cosines. Now with this, again, for reasons beyond the scope of this class, I'm going to give you guys the tip in which one should you go for first. No, the order in which you label the sides do not matter, but I guess for our examples, if you kind of copy what this says here, it would be helpful. So in this tip for side, 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 can you guys go ahead and write this out? Okay, it's because sine only accounts for values between 0 and 90. If this triangle ends up being obtuse and you start off with the law of sines, it's not going to account for that. So when solving with three sides that are given, because cosine does account for things that are obtuse, you're going to want to find the biggest angle first in the event that it is obtuse. Okay, so in this case, the tip is going to be when you're solving for this triangle, when solving a triangle given three sides, find the largest angle first. Okay, so can you guys tell me, if I'm looking at this picture, which would be the largest angle? Okay, it should be the angle across the largest side. So in this case, very good, angle C. So if I begin with angle C, then I remember that with my law of cosines, the angle comes at the end. So it's also going to start at the very beginning with C. So little c squared equals, think Pythagorean theorem, a squared plus b squared. The middles match, minus 2ab, cosine of capital C, or angle C. Now let's go ahead and plug everything in. We have 6.5 squared equal to 5.6 squared plus 1.8 squared, keep going, minus 2 times 5.6, 1.8, cosine of an angle. Okay, Phoebe, no worries. All right, you guys, so we got one giant formula. Sometimes when you guys flip open a textbook, along with the three formulas that you guys have that I started off with at the beginning, you might find another three set of formulas. And I don't write that out as a secondary thing because I think you guys can, after a while, like I know Christian, he just started to pick up on the pattern every single time I solve for this, I'm multiplying this and then dividing by this. You're going to start to notice the same thing with the law of cosines. And I would rather you guys do that through discovery than through another three sets of formula. So here, at this point, I want you guys to think of it, and I'm going to underline it so that you see what I'm saying. This is what we call a term. Terms are things separated by addition and subtraction. So one term here, one term here. So you got the addition here, subtraction here, and it's subtracting this giant term here. So really, you guys just have three terms here. So if you guys got three terms and you're trying to isolate cosine of C, to move the 5.6 squared over to the other side, how would you guys move 5.6 squared over to the other side? I'm trying to isolate cosine of C. What operation would you guys use to move 5.6 squared over to the other side? Subtraction, right? I would subtract 5.6 squared. How would you guys move 1.8 squared over to the other side, the other term? Once again, it's just a term that's being added. So to undo the addition, we would subtract the 1.8 squared. And then eventually, I know you guys are going to probably do it all in one step, but I wanted to make this a step. Okay, then I have a couple of things on my last term that are all being multiplied together. -2 times 5.6 times 1.8 times cosine of C. How do I move these three factors over to the other side? divide them all at once. Divide. If it's being multiplied, we're going to, let me do that in a different color. We're going to divide -2 times 5.6 times 1.8, and eventually this is going to be one step for you guys. And lastly, perhaps the biggest mistake is assuming that after you divide that that's your answer. What do you guys got to do to get angle C by itself? What do you guys have to do to both sides? How do you undo cosine? I know, right? Inverse cosine, that's a gigantic expression that you guys have now. So you're going to apply inverse cosine. I'll just put it in brackets here so it's a little bit more visible, but the expression that you're eventually going to enter into your calculator is inverse cosine of all of that. Okay, so it's really important that you are able to do this all as one expression into the calculator. So I wouldn't round along the way. Let's practice doing this. So let's go ahead and go into Desmos. Please, everyone, do this along with me. What happens is it makes sense when I'm going over it, and then when you do it on your calculator, you might have a question. And order of operations is super important. So go into your calculator, clear all. Okay, first step, make sure you guys select the fraction capability. Okay, select the fraction. And then that's going to automatically divide out the numerator and denominator. So you don't have to worry about like PEMDAS and do I need an extra set of parentheses. If you guys would like the extra set of parentheses, you guys can enter it in here at the top, but you would do 6.5 squared minus 5.6 squared minus 1.8 squared. Move to the bottom at that point, and then divide out by -2. And I forgot to enter inverse cosine, but we can do that after. -2 times 5.6 times 1.8. And let's say you guys have that all and you want the inverse cosine in front of that. So inverse cosine function, inverse cosine of all of that. And yes, Cody, that is correct. So here is an example where you do end up with an obtuse angle. So had we saved the obtuse angle to be used for law of sines, it wouldn't have picked up on the correct answer. So we want to make sure that we always start off with when we have 3 sides, that we start off with the longest side to solve for the largest angle, because cosine will find that obtuse angle, sine won't. Okay, so in this case, 112.3, you guys here doing okay? Okay, so angle C is equal to, the measure of angle C is approximately 112.3. Okay, if I had to solve for everything that was missing, now I have C. What do you guys propose moving to next? What would you guys use to solve for next? Law of cosines or law of sines? Sine. Okay, since you have C now, go ahead and use law of sine. And you have to start with C because C is the only one you have the angle measure for. So sine of 112.3 over little c. And then at this point, you already have the obtuse angle, or the one that could possibly be obtuse that ended up being obtuse. So you can pick whichever one you want to solve for next. So if you pick for, let's say A, you would do sine of angle A over 5.6. And then continue to solve the rest of that. Go ahead and solve, verify that you guys have the same answer. Yeah. Yes, that's right. Good. If you guys missed anything on the notes today, I'll upload these notes onto the agenda today.
I still don't get how you got six root from minus 5.6 squared, but minus 1.8 squared over
So okay, so the recommendation is to, when you're given three sides, find the largest angle first. Largest angle is going to be across the biggest side. So if I start there, that's going to be C. So C is going to be the,
I'm talking about like cosine negative 1.
this one?
Yeah.
Oh, okay. So you subtract 5.6, subtract 1.8, that's this. Then divide by all of that to isolate cosine of C. Yeah.
Okay.
Order of operations, subtract the terms, divide by the factors. And yes. Okay, good, you guys. So once you guys, I have a few people who are done with the problem. Once you guys are done, can I have you guys go ahead and the homework tonight is just to finish the two worksheets that you have started with the law of sines. They're a mixture of law of cosines and law of sines. Go ahead and start and see if you guys have any questions for me. I'm going to work with some of the kids in the class here as well. Angle B, by the way, once we have the other two angles, we can simply just subtract out the sum of the other two angles that we solved for and get the third angle for angle B is equal to 14.8.